Howdy, everybody. I'm Professor Parks, PhD, and I make content on astronomy, science, skepticism, and mental health. And welcome today for another episode of Shouting into the Void. Today, I have a smattering of different little topics that I want to put together. The impetus is, of course, the upcoming SpaceX launch to the moon. But I'll also be talking about ingenuity and what else? Wow, my memory is really, really horrible. So hopefully it'll come in. I'm just about to give you an update on C-STAR, the telescope that I would like to purchase for myself that I will graciously loan to the observatory during public events. So, alrighty then. Roke, haven't seen you in an age. Howdy. Let's see. Where should we get? All right, let's do this. Let me. I will say that I am not overly prepared today, so this is going to be kind of off the cuff. But when am I ever prepared, really, honestly? So yeah, due to my recent fortune of becoming monetized, I have set a goal for myself to actually use the money to, again, further the observatory, and particularly our ability to do public outreach. Now, the last thing that was purchased by my patrons was a planetary camera, which sadly hasn't gotten a lot of use recently because the clouds have not been very cooperative. Weather here in the winter is more mist than hit. In addition to that, the telescope tracking system seems to have gone kablooey. So that's something I'm going to be doing tonight. Woohoo! Trying to do a project with high school students, and I had them come out for the last 2 nights, and yeah, they did not go well. Both times we had to cancel because of technical issues. So this time around, I prefer not to have 3 strikes. I told them to hold off, and tonight I'm going to fully diagnose and treat the telescope. Hopefully I can fix it. And if I can, that'll take some data for them tonight. We'll see how that goes. Oh yeah, I remember what else I wanted to talk about. 1 second. I got a prop. Okay. I can't see anything now because what I have on are solar eclipse glasses, are glasses that are specifically used to look only at the sun. You can't really see anything because it knocks out about 98.999999999% of all light. So yeah, pretty much the only thing bright enough to actually see anything is, of course, the sun. So I can't see where the camera is, so apologies. But the reason why I have these things on is because of an eclipse that's going to happen in North America. Sorry, Judy. Sorry, Clive. Sorry, Roke. That's going to happen in North America on April 8th. It is going to be a total solar eclipse. Now, for us Americans, we have lived in an unprecedented age in that we have not only had 3 solar eclipses within the last 6 years, we've had 2 total eclipses in the last year or 6 years. The next total solar eclipse, or really any solar eclipse that you can see in the northern continental United States, will happen in, I think, 2044. So 20 years from now. I plan on being around, or at least die trying. And so yeah, the reason why I bring this up is because if you are in North America, please look up the details on the April 8th eclipse event Although I could probably do that later today. All right, let me take these off so I can actually see comments and stuff. Let me put on my other glasses. Clive, are you Jewish? Because I've heard that there are giant Jewish space lasers causing havoc causing California wildfires. Um, but yes, I know Dr. Wells is going to put a giant laser into space for the benefit of all mankind. He is certainly not going to use it to burn away all of his detractors and quickly seize power in a Palpatine-ish sort of way. No, he would not do that. He is going to benefit humanity with his space laser. But anyway, getting back to April 8th, and at the end, I will find more things. Anyway, what I wanted to talk about is if you are in North America, find out details. If you are in the following cities, then you don't have to go nowhere. That would be San Antonio, Texas. I think Dallas, Texas is in totality. Indianapolis, Buffalo, Cleveland, and Evanston, Illinois, I think. So we have major metropolitan areas that are going to be in the path of totality. Now, why is there something called the path of totality when anybody who can see the full moon can see a lunar eclipse? That is because the moon is small in comparison to the Earth, so therefore its shadow is small, and it barely reaches the surface of the Earth, and so that area, that footprint of that shadow, is fairly narrow. I've heard it depends on the eclipse, obviously, but you're talking about maybe, I want to say 100 kilometers in width. So it's comparatively narrow. And I'll get to that in a sec. Tiny. Where was I going with that? So yeah, it's going to happen on April 8th, and depending on where you are, on average it's going to be about noonish. It's going to be about noonish here. In Fairfax, we're outside the path of totality, and also Washington D.C., basically the same place. We're 80%. We're going to see 83% of the total eclipse. GMU, George Mason, is going to be hosting essentially 3 events. We're going to have 2 away teams and 1 home base, and we are sadly just now really getting around to becoming to actually organizing this thing. And if you are any kind of eclipse watcher out there, you realize that we are about 10 months too late to do this properly. If you properly want to actually find a location with accommodations and places for you to set up, you really have to look a year in advance. Apparently the director, Peter, looked in Indianapolis and booked solid. So we're going to have to figure something out. But the 2 away teams are, one, as it happens, the American Astronomical Society somehow, I don't know how, maybe they use a Saros cycle, but they knew that there was going to be a solar eclipse on April 8th. And so what they did was that they cleverly decided to hold a conference. We have 2 conferences. We have a summer conference and a winter conference. There are tens of thousands of astronomers who are part of the society. It's a huge deal. It's a big thing. I may have mentioned it before. Yeah, with the joke poster last time. And so they're holding their winter meeting in Dallas. So one of our professors is going to take his grad students to Dallas, and he's going to set up one of our telescopes and attempt to actually take video of the eclipse. Now, another team, place to be determined. As I said, we looked in Indiana. We thought about going to Case Western in Cleveland, but weather sucks in Cleveland. Particularly if you're on a lake, particularly Great Lakes, you're going to get a lot of clouds, from my understanding. And also, just statistically speaking, the further north you are, the greater chance you have of being clouded out. Here we probably have slightly better than 50-50. But as like I said, as you go south in Texas, like South San Diego, Dallas, you're probably shooting 1 in 3 in terms of getting clouded out. So yeah, so we thought about Cleveland, Case Western, because they are having an event themselves. Case Western's having an event, but we said no, we want better chances. So we're now looking in Indianapolis. One of my grad students, yeah, Roke, if I believe you are in Brazil, maybe Argentina. Apologize, I know those are two very, very different countries. You're definitely in the southern South America. So yeah, not so much of a chance for you. Those of you who are in Mexico, I shouldn't internet. Folks of you in Mexico, I know it will go through the state of Durango at some point, or when it comes in. Other states, I'm not entirely certain. It's also going to go through the land of Newfs and New Brunswick, from my understanding. So, path of totality will be well south of the Great Lakes. Not Lake Erie. It'll be pretty much on Lake Erie. So Buffalo is Buffalo's there. Like I said, Cleveland's going to see it. Argentina. All right. Okay. I will not make that as a mistake again. Because I know you guys have a serious football rivalry with each other, like way serious rivalry. All right. Because I'm vain, I'm going to switch back to me. So that way you can see my beautiful face and hand gestures. Anyway, so one of our tour guides really wants to go to Memphis. That's another big city in path totality. Memphis, and I really love this plan because one, Beale Street, blues music, and barbecue. Memphis barbecue is, I wouldn't say it is as good as Texas barbecue, but it's pretty up there. Not as hot as Nashville. No one gets as hot as Nashville when it comes to barbecue, but Memphis, yeah, good times. But it's like 13 hours away, and some people seem to think that that's too far. I don't, but I'm probably going to get outvoted. Anyway, and then finally we have a home base event, and that is currently very much a cluster hug. We are trying to negotiate, or we're trying to get to speak with somebody at the university level, because the day before we're going to have a whole slew, like 1,000 1,000 high school students who have been accepted to George Mason but have not necessarily committed. And so there's going to be a whole, hey, we're awesome, come see us. And they want us to do an observatory thingy do. But since almost all of us are going to be out of town, director doesn't really want to do that. But the reason why I bring the other reason why I bring all this up is that I may have to stay here, which really sucks, because we don't really have anyone who is appropriate to MC this damn thing. And since we want to boost our presence or our profile in the community, we're not just going to skip it, and we're going to promote it if I have anything to say about it. So we need someone appropriate to MC the damn thing. The only stumbling block is we may not have enough student volunteers to staff the thing. So TBD, but you will be hearing me talk about the eclipse many times before. Yes, Erie will be, but the other four Great Lakes are not gonna see it, but Lake Erie, yes. So Tiny Captain, let's see. Tiny Captain says, do you mean you have glasses that when you have them on, you can see the sun without the glare and you can see it changing its size when it's setting? Magic glasses? I actually have never done that. I have never actually taken a pair of eclipse glasses and looked at the sun when there was not an eclipse happening. that might be something to try. Although that does remind me, I do have one student guide who loves solar astronomy. I mean, he can't seem to get enough. He's constantly taking out our solar telescope and taking out our solar telescope to show to students on campus. He's our president of our Friends of the Observatory. Jonathan, if you're watching, yes, I'm talking about you. And what I would like to do is trying to think, the observing deck, we don't have great sight lines east and west. We have trees and a building. So we can't see it on the horizon, but we do have a good swath of the sky. And what we could do is, well, we have the planetary camera, and that's not going to work. It's too small. We might have a camera where we can capture the whole thing. We do have a camera. We've done it before. We can capture the sun in the field of view of the camera, and we can do a rigorous test of how big it is. What is the apparent size of the sun as it crosses across the sky? And we can, at different intervals, we can take images every, say, half hour or hour if we're feeling lazy, and actually do that measurement, or take those images and analyze them and actually get the measurement, and then compare that to the expected plate scale. Yeah, we can do this analytically. We can actually throw data analysis at this, and we can see just how the size of the sun changes its angular size as it passes through a significant swath of the atmosphere. Like I said, we don't have great sight lines to the west or the east from our observing deck. If we do it if we do it on the parking deck, then it might improve our east, but it's certainly the west is gonna suck. Anyway, thank you for reminding me, or thank you for bringing that up. It's something I've been having on the back of my mind. Solar angular size test. I will remember enough that after this, I will actually ping Jonathan on Discord, and that way he'll remember, so we don't have to worry about my goldfish memory. Flourish to use eclipse glasses when watching and reading scientific evidence. Possibly. Yeah, very well. I did just see Witzett's explanation. I don't know how old it is, but Witzett was, someone asked him, how do moon phases occur? And his response was interesting. Apparently, I can't repeat it because it was somewhat word salady, and so it didn't quite make a whole lot of sense. But what I'm getting is that the ether kind of coalesces or charges somehow magnetically. And so when it's low power or has no charge, the ether is dark. And then when the ether charges up, somehow it waxes, it gets to full, and then apparently it discharges. So apparently the moon is a capacitor of some sort. And then that cycle repeats itself. And I thought, wow, that's novel. I haven't heard that one before. I've heard plasma. I've heard hologram, obviously. I've heard clouds. That's the most common among general public people, is they believe that either is clouds or it's the Earth's shadow blocking out some of the light, which is a pretty good guess. Of all of them, that's the best guess. But as hopefully we all know here, the phases of the moon are caused by the line of sight to the illuminated portion of the moon as the moon orbits around the Earth. The only time the Earth's shadow cuts in the way is for lunar eclipses. Other than that, the shape of the moon is caused by our perspective. Yeah, I know, Clive. It is hard to believe that Witzett's would speak in word salad, but That's certainly what I thought. That was my opinion. Um, let's see. Uh, Caused by aliens? Well, there was that documentary, Moonfall, which told the world that, in fact, the moon is a alien megastructure. But I've been told that was pirated. That documentary should not have aired. So, as part of my still receiving of NASA checks, I have to deny that actually is real. That is in fact a movie, rather than a documentary. So, no, it's not aliens. I don't know. I haven't talked to Austin in a while. As I've mentioned before, I give Austin quite a bit of the reasonable doubt for reasons that I still don't quite understand. Maybe I'm charmed by him. I don't know. I understand that he has some problematic beliefs, but he has never vocalized them to me, and I've never heard them. I do know how he feels about who started World War II, which I greatly disagree with, and have told him that. But yeah, I don't know. I don't know about him. Yeah, when it comes to the major players in flat Earth these days, specifically who I'm thinking of is Austin Whitsitt, and Jaron. Then obviously you have the up and comer Alan Space Audits, whom I really want to have a conversation with again, because he is. I don't know if the conference has happened yet, but he very quickly has risen in the ranks within the flat Earth community, and is now actually a speaker at one of these conferences. Let's see what else. Who else am I thinking of? Oh, Shane St. Pierre. And then finally, the one I have yet to encounter anywhere, actually, I've only heard of is Dave Weiss. I'd really like to talk to him to figure out what his deal is. I think he is unlike Mark Sargent, I think he is a true believer. I think Mark Sargent used to be a true believer, but he now is so pot committed that he can't possibly move away from it. He actually admits this in the infamous or famous Netflix documentary Beyond the Curve, whatever that is, whatever it was very interesting. So yeah. Jaren's moon landing denial live stream last night was particularly egregious. Oh, okay. He actually talked about moon landing denial. Yeah. The thing is about Jaren, and I don't want to backtalk or don't want to, talk bad about people, particularly behind their back. But what I found to be problematic with Jaren is that he's non-committal when challenged. Like he'll make declarative statements, and then when challenged with evidence, my experience is he acquiesces. He simply says, "Okay, whatever." And I guess I've done that on occasion. Like for example, with Austin, he brought up the long distance radio transmissions, and I told him I had no idea what that was about. I have no experience with that, so I can't comment. And I just said, I'll look into it, which I actually have, and so a little bit. So there's something called tropospheric tunneling. I don't know. Obviously, I've looked into it a lot, but there are particular methods on that chart that he gave me, and he has shown there's a code that indicates the atmospheric conditions that were made it possible to actually see those or to hear those transmissions at such long distances. It was not ionospheric bouncing. Atmospheric ducting, thank you. But there's some real astrophysics derp check out on the Aether Cosmology server. I don't know. I don't know what to do with the Aether Cosmology crew. because I just, to me, it strikes me, and again, this was not what I had planned on talking about, but I'll entertain it for a little bit. So with the Aether Cosmology crew, I will give it to them. They have researched the shit out of the history of that era. Now, do they cherry pick? Maybe. But what they certainly do is they certainly do have certain confirmation bias, is that they find the things, the contrary opinions at the time, treat those as gospel, or, the more probable, and then everything else is not worth talking about. I don't think that they have. The most recent thing that I've seen that I have to still have to check out is apparently Alan has found a paper that suggests that the speed of light is not constant, is not direction invariant, and this is shown in GPS readings. I haven't looked into it. I don't know. I suspect it's going to be a claim of, I think they are claiming that it's backwards engineering, that they know that the speed of light has to be invariant, and so that there's code in the GPS system that forces that reality, which to me would then just be a misconception. But I know so little about the, Panicare's contribution. I think it's Laplace, all of those folks, their particular contributions to GR, particularly in the early 1900s, that, I have nothing to say about it. All I can really point to is, why does it seem to work now? Like, yes, apparently there are a few folks who have done experiments. The Sagnac effect, for example, has shown that the Earth is not rotating or something of that nature. But the vast majority of experiments show that it does. So Toon has kind of taken the charge on combating this by looking into the various things. And I know I Can Science That has also spoken with Alan, although I believe their relationship has significantly soured. But yeah, and honestly, while I do want to learn about that era, I don't want to get into the weeds with it. I have way too many other things on my list in terms of priority that I want to get to. For instance, I am now reading Carol's book. On my Discord, I asked the question, something akin of, can you think of space-time as a gravitational field? And Clive has put in some valuable insight on that. And Electro, oh Lord, I can't think of their handle, but there's another one on the channel that has added a lot of insight as well. So I have decided that because of their responses, and particularly my ignorance of what the hell they're talking about, I seriously need to look into this. That this is not a trivial question, even though I think I'm onto something, but certainly my knowledge is not up to snuff. So I'm reading Carol's Space-Time and Gravity and Space-Time. I think it's what it's called, something of that nature. It's a huge book. It's a huge tome that is directly related to this question, whether or not space-time can be thought of as a gravitational field. From the first chapter, I can tell you the answer is probably going to be no. That the gravitational field, fields in themselves, like an electric field, are laid over the space-time geometry. So I'm still confused on whether or not there is, in fact, an electric field. I don't know. But chapter 2 is going to go over manifolds, which I don't know what those are. So once I have a better understanding of manifolds, then I can understand Clive better. Electroneutrino. Thank you, Dr. Wells. So once I understand manifolds a hell of a lot better than I do now, I can actually start making sense of what Clive says on my Discord. And maybe at that point, when I'm a bit more literate I'll invite him on and we can actually talk about this in a lot more detail. I would rather spend my time learning that than I would to learn the history of Aether. I mean, to finish out this thought, and if Alan or any other Aether believer out there, Aether, there's anyone out there who believes in the Aether, my bottom line is the same thing that I have for any other flat earth theory or science skepticism theory, is that for me to really take it seriously, what needs to happen is that you need to provide a rigorous mathematical framework or physical framework for how I'm going to back off that. You don't even need to do that. For me to actually really start taking you seriously, you need to start describing how Aether would explain apparently time dilation effect in GPS is a question. Muon decay, the detection of muons at ground level from cosmic ray events in the atmosphere. How does Aether explain that? When you can give me a physical reason for it that isn't word salady, then I will really pay attention. I will look into it. I promise that I will. But until then, until you can actually explain already well-established phenomenon, well-explained phenomenon that uses GR, I don't see you're spinning your wheels. You're not going anywhere. You're not going to convince anyone unless you can actually already describe. The flat earth movement, particularly in this case, is all about knocking holes in theories. That's not what science is. What science is building. We are not in the process of destruction. We are in the process of building. So unless you can come up with something productive, then I don't know where we can go from that. And also, I want to say this, and I think it's a long time coming, is that I do not accept this argument that you don't have the funding. I do not accept this argument that you have, that we've had so much time to develop blah, blah. Well, according to some, people have been thinking about this for at least a century. And I want to remind y'all that Einstein came up with at least the rudiments of relativity while working as a patent clerk. Didn't take him a lot of money. He didn't get any funding. So when it comes to questions like this, you don't need funding. You just need a whole lot of people, or you need to be very clever in doing this. And so if you think you're up to the challenge, you don't need funding to do this. And this really is a general statement for those of you who are out there, science skepticism or whatever. When it comes to these big ideas, I don't think you really need funding to do them. You just need to figure out how to be clever about it. Now, rigorous testing, that requires precision equipment. Yeah, that requires money, and funding. But anyway, yes, it's a mistake to confuse the history of science with science. But anyway, maybe that's why so many people are questioning Einstein. Howdy, Stephanie. I don't know what I said to precede that statement, that so many people are questioning Einstein. Probably had nothing to do with funding. But yeah. If they could come up with a better reason or better explanation for why the moon phases occur using Aether, than what I heard from Austin, that would definitely be an improvement. Could be. That's why so many people are questioning Einstein. He was just a patent clerk. Well, doesn't that seem a bit hypocritical, considering that a lot of the movement that I've seen, and a lot of the motivation behind the movement, is that science can be done by non-experts. So if you're questioning relativity because he was just a patent clerk, then why shouldn't I question everything that comes out of the mouth of Austin Whitsitt or Allen, because I don't know what they do for a living, but I'm fairly certain they are not professional scientists. So, yeah. So just I would say that the word "just" really doesn't apply to Einstein when it comes to his way of thinking. So you can question Einstein. I'm not saying you can't. I'm not saying you can't question Einstein. I am. What I'm saying is questioning Einstein because he was a patent clerk, I think seems to be a bit hypocritical, particularly in. No, I'm not saying you're a hypocrite. What I'm saying is in the context of what I've heard from other skeptics. But no, I've always said you can question Einstein, but you I don't know if you heard it before, but ultimately what you need to do, in order to get people to listen, you need to be able to have an alternate theory, and have that alternate theory explain what has already been explained with GR. Instead of trying to punch holes and say that GR doesn't explain yada yada, be more positive. Tell me how the Aether explains it, and preferably how the Aether explains it better. So, Meraki, I don't know. I don't know what Alan does. I believe Austin's job is YouTube, which is valid. Whether or not we want to agree with him or not, anyone who makes money off of YouTube and can support themselves through YouTube, that is a valid profession. All right. Anyway, that's kind of the last thing I want to talk about in terms of that. And yes, I have my light right next to me, which I know is thoroughly unprofessional, but all right. So, yay, monetization. So I am monetized. Like I said before, due to my generous donations of patrons, I now have 3: Judy, Dora, and Norman. I was able to afford to purchase the observatory a planetary camera. Next thing that I'm going to purchase, which I am now, as of today, 30% there, is this little thing, which is a C Star. I think before I called it a Day Star. It is a C Star S50 by the company ZWO, which apparently is a Chinese company, if that makes any difference to you. And they make excellent products. All of their cameras so far, I can't speak to how robust they are in a long term, because I haven't seen anyone use a ZWO camera for like years, but out of the box, they're fantastic. There is this instrument called an EV scope by Unistellar. And the motivation behind these particular instruments is having a telescope that is very easy for someone in the general public with little to no observing experience to be able to take high quality astrophotography, or to do high quality astrophotography. In fact, there are friends of mine in Novak, the astronomical club. Some of them kind of look at this as cheating, because of all the effort and expense they put into their own astrophotographic rig, that these things really just kind of undercut that a little bit. But anyway, these are designed that. But also, in addition to that, because of the endemic problem that is light pollution, that we are losing our night skies. Here at this site, we have, when it comes to limiting magnitude for the eye, I would estimate it's about 4. Just to remind you, 6th magnitude is the lowest that you could see when at all. Like that is the limit as defined by Hipparchus. So you're talking about 2.5 squared, whatever that happens to be. That is the difference in brightness between a 4th magnitude star and a 6th magnitude star. Here, when it comes to number, I'd say that we have, maybe 50 stars. At 6th magnitude and on a good sky, you're seeing thousands of them, to the point that if you put me in a good sky, I lose all of the popular. Like, I will have a problem finding the Big Dipper. I will have a problem finding Orion. Corona Borealis, though, just pops out to me immediately, even though I can only see that in a dark sky. In this sky, I've never been able to see that constellation. So the Nikon P666. Oh yeah, Dr. Hamden's talk. I'll talk about that in a moment. But these telescopes are designed to compensate for light pollution, and the way they work is, to call them a telescope is, when you think of a telescope, I think when the general person thinks of a telescope, they think of, something that it has a lens or a mirror in it and an eyepiece, and you can look through it. And these, not so much. You cannot look through these. These are 4-inch aperture lenses that focus the light onto a CCD or digital camera. And by integrating over time, you can defeat light pollution. You can see deeper into the field, but they're really easy to use. Thing is, we are on order. We have an EV scope for the department, for our observatory on order, and eventually we will actually go through come out the other side of the labyrinth bureaucracy and actually get that ordered. But I'm trying to see whether or not I can order this before that comes in. The EV scope is a great instrument, but it is about 4 times as expensive as this little one. This little one's about $500. The 105 that you see quoted here, if your eyes are better, that's for the tripod. Well, that's for a more robust tripod. When you buy it at this price point, at the $500 price point, you get this little dinky desktop tripod. But the good thing is, this camera or this telescope will fit on any 3/4 inch of photographic camera, camera tripod. So, which I have one right over, well, there. This camera is on it. But yeah, it's very easy to set up. You can use, and yes, this stream is unofficially sponsored by C-Star. You can use apps to control it. If it's anything like the EV scope, you can actually have multiple people who have a Bluetooth connection to the scope, and then you can designate who is the operator. So if I have a group of, it's me and 8 or 9 students, what I can do is I can control the telescope. I can make it look at, say, the Crab Nebula or Andromeda Galaxy, and I can talk to them about that. And then I can pass the controls over. I can pass the controls over and say, hey, figure out what you want to look at and go look at it. And we can all enjoy that. So I think that is a tremendous power to it. Apparently, it also has a couple of snazzy photographic modes that allow you to see various things. So it not only is useful for astronomical viewing, but apparently also terrestrial viewing as well. So yeah. And I'm going to look into this, which is the solar filter, which for some reason is not H-alpha. It's typically for telescopes, filters are neutral density. Like the ones we have for our bigger scopes are neutral density. They're basically just like this, only they cover the cap of the telescope. This is what we call a narrowband filter. It blocks out all of the light except for a small portion of it. And normally, when you do that for solar observing, you look in H alpha, which is where a lot of hydrogen emission is, and you can see a lot of really cool structure. For some reason, they decided to do a filter that's just up to the H alpha, but does not include it. I don't know why. I'm assuming it has something to do with the manufacturing process, but it apparently is going to give a little bit better. So I'm going to look into that, but I'm putting the cart in front of the horse. Like I said, if you'd like to see this, if you'd like for us to have, well, for me to have one, I'm not donating this one. This is for moi. I will be using it with the observatory and with classes, but it is for me. If you'd like for me to have this so that I can educate, please consider becoming a patron or send me cash on PayPal. You know, whatever, or become a channel member. I have memberships now. Woohoo! So that's always cool. So yeah, that's the update on Seastar. Like I said, I'm 30% there so far. Does your new telescope have a laser sight on it? It does not. But what's really cool though is Gemini North and South. They use an adaptive optics system, which I'm not going to get into here, but they use a guide star, which literally is they strap the laser to the telescope's frickin' forehead. And so they shoot a high-powered sodium laser light into the sky. So yes, those in fact do have a laser sight to them. All right, so now let's talk about SpaceX, which ordinarily I don't like talking about because of a certain Mr. Musk. But so balloon telescopes. So yeah, so if you don't get the notifications, click on that bell for notifications, and you will have been notified that last Tuesday, Dr. Erica Hamden from University of Arizona, one of the more prestigious astronomical universities in the United States and arguably the world. She was kind enough to give us a talk. Her talk was a mixture of really just emphasizing the importance of what we call multi-messenger astronomy. What that means is multi-wavelength astronomy. So not just looking in the wavelengths that the human eye can see, but looking in the wavelengths that the radio, that happen to be in the radio or in the infrared, or in her case, the ultraviolet. And if you can do that, you are looking at different physics. You're looking at different temperatures. You're looking at different types of, or different events that are happening at different energy levels. At radio, you're looking at cold, low energy kind of phenomenon, like really slight transitions in the hydrogen atom, and then with gamma, or with ultraviolet, you're starting to see the effects of kilonova, of neutron stars colliding. When they do so, they explode, and a lot of that energy is in the ultraviolet. And what we can do is we can take all of that energy, and in some cases, if you look at a single object in multiple wavelengths, like a galaxy, depending on what wavelength it is, you are looking at a different part of the galaxy. A galaxy can look dramatically different depending on what wavelength you're looking in. So it's very important for astronomers to not just look in a single wavelength, but in many different wavelengths so we can have a more complete picture. She also then talked about her own work. And just real quick, another shout out or another point. If you are a member of my channel or a patron, then I have already posted this talk completely unedited, so you get to see how charming I am in front of an audience. And you get that as an earlier release. So if you're interested in that, please become a channel member or part of my patron or one of my patrons. So ultraviolet, as you might expect, causes cancer. causes skin cancer. So a whole lot of it is really bad for us. So we have evolved, or I don't know. This is kind of a chicken and egg thing. But anyway, the atmosphere is fairly opaque to ultraviolet radiation, meaning that it does not allow a whole lot of ultraviolet radiation to pass through and down to the ground. Now, in the near ultraviolet, those ultraviolet wavelengths that are close to the visible range, enough of it does penetrate through the atmosphere, and I believe this is called UVC. Enough of it does pass through the atmosphere that you do run the risk of getting skin cancer if you're overly exposed. But UVB and UVA, not so much. And so when it comes to observing these wavelengths, you're left with two options. Either one, high altitude balloons like weather balloons, or two, space telescopes. She specifically looks at, or has a team of graduates and undergraduates who build instruments for basically UV cameras for balloons. And so she sends out fairly regularly these hot helium-filled high altitude balloons so that she can get as high up into the atmosphere as possible. She actually showed footage of one of the cameras that actually was in high altitude and showed the curvature of the Earth. I didn't have the heart to tell her that that's not going to convince someone who's a skeptic because there's obvious barrel distortion, but yeah, so she mentioned it. So yeah, a good portion of high energy astronomy is done using balloons because it is way cheaper to do that than to have to continually build and send up space satellites. So yeah. Howdy, Sable Eagle. Haven't seen you in a while. So, Stephanie, if you have any specific questions about that, I will try to answer them if I can. Now, early on, I saw a comment by Dr. Wells that he would not trust SpaceX with his life. That if we are going to have any kind of lunar landing, because obviously the title of the stream is SpaceX going to beat Russia to the moon? Now, I will preface this by stating that this is an unmanned mission. SpaceX is not attempting to put anyone on the moon. They're attempting simply to have a lander land on the moon. Very much like what India did, and very much like what Japan did fairly recently. So this is if successful, this will be the first commercial effort to actually have a successful soft landing on the moon. There was a previous attempt by a company known as Astrobiotics. Presents that one. However, it didn't work. So it was put up. Launch was good. It went out there, and apparently it suffered a critical failure in its fuel system. Apparently something with the oxygen seals, I think. Blue Moral Science told me, but it kind of went one ear out the other. All I know is that there was a problem with, I believe, the fuel system, and it could not land safely on the moon. So instead of just having it smash into the moon, they decided I think they had enough power that they were able to redirect it and have it safely re-enter the Earth's atmosphere. And apparently, I thought this was upcoming, but apparently this happened on Thursday, January 18th, according to Astrobiotic, and it burned up somewhere over the South Pacific Ocean. I wonder if years from now, if there is going to be industry of divers. You have wreck divers who go down, try to find old ships and, putsy around in there. I wonder if there are also going to be a subsection of those who try to find spacecraft that have been, deorbited and landed in the ocean and try to find those. fairly recently, the biggest thing that I knew of was I think it was Apollo 11 booster rockets or booster rocket. I don't know, part of the Saturn V. I'd have to look into it again. But Bezos actually sunk in the money to do a rescue mission, and that component, those rocket or those engines or motors, are now in the new wing of the Smithsonian, which I still have yet to have the time to go actually figure it out. All right. It's just nice to know someone admitted balloons are used, and I thought she called these balloon telescopes. Then balloon telescopes. Sorry if I misheard. They are balloon telescopes. Well, they are telescopes that are carried aloft by a balloon. And so I don't remember her saying it specifically, but I would not be surprised if she referred to it as a balloon telescope, because we refer to them as space telescopes and then ground-based telescopes. But I don't know who you're talking about, but we've been doing balloon astronomy for a long time now, particularly when we have been able to figure out how to create cameras that are sensitive to the UV and X-rays. I don't think we've ever done gamma ray astronomy with a balloon, but I could be very wrong. But as soon as we figured out how to actually collect photons in those wavelengths, yeah, we've sent balloons up. There is a sub-department of the physics and astronomy department at LSU that does exactly the same thing. I think their wavelengths are X-ray. They kind of kept to themselves, so I didn't have a lot of interaction with them. But yeah, LSU does it. So yeah, they are. Howdy, Al Trucker. Hopefully you're not currently driving. Yeah, we've freely admit that is definitely a thing. That is one thing in our arsenal. The weirdest observations that I really am just absolutely fascinated by is this idea that they put They put a telescope not once but twice into a jetliner and flew it around. So the one I'm thinking of is Sophia. I can't remember the name of the first one, but you have Sophia, which has now been decommissioned. And the idea, our telescope is sensitive enough that when the air conditioning in this building kicks in, we see the vibrations. So the idea of having a telescope that is stable on a friggin' jetliner traveling at 30,000 feet. I don't know if you have a lot of turbulence there, but I would suspect you have some. Is just the amount of engineering to go into making that thing stable. It's got to be mind blowing. Like I thoroughly thoroughly impressed with it. But anyway, this was the Peregrine lander by Astrobiotics. It failed, so SpaceX is now trying. And share screen. SpaceX. Yes. Boom. Yay, ads. So Intuitive Machines is created something called Nova C Lander, and it is expected to launch sometime this month. I believe it is 22nd. Yes, will take place on the 22nd. If not, then they will try again in March. And what I mean by if not is basically if the weather doesn't cooperate. So we have these things called launch windows because the things in the because the Earth is moving, because the Earth is moving around the sun, the moon is moving around the Earth. In order to save cost, you want to launch this in certain windows such that trajectory is such that you don't have to fight against the gravitational field that you're flying through, because it doesn't make sense. You can't, well, I suppose you could just send it straight at the moon, gravity be damned, and just try to brute force your way down there. But it's much easier to follow along particular trajectories and allow gravity to help you rather than to hinder you. So we have these launch windows where everything is aligned just right. so that can occur. This is going to be landing somewhere. Where is it? In the South Pole. It's going to. Apparently, it's going to be a precursor. It's going to be used as part of the Artemis program to find appropriate sites for landing and data survey. But this is primarily going to be, where is it? Impact crater called Malapert A. Great place, lovely vacation spot near the South Pole. And you may have seen, like, India did this, the Japanese did this. The South Pole is rapidly becoming the place to go for lunar landers, and I believe the first Artemis base is scheduled to be put on the South Pole. And the reason for this, and this will probably be the new, the eventual new resource race, as it were, is ice, specifically water ice. Because they are at the poles, and because the moon's axial tilt is pretty much not angled with respect to its own orbit or the ecliptic, sunlight, the craters are deep enough that the bottoms never receive direct sunlight. Therefore, ice can exist on its surface in a solid state. Right now, ice exists underneath the regolith. Basically, if you were to dig down about 6 inches or so, you start getting into what is known as the permafrost, which is this layer of slushy ice. Well, maybe not slushy, but definitely water ice underneath the surface that pretty much coats the entire moon. But for these craters, you have these sizable deposits of water ice, which the Indians actually were the ones who first figured this out with one of their orbiters. Water ice is going to be crucial for habitation. Obviously, you need it to drink. Presumably, you'll need it to bathe. Although, yeah, being in a trapped, sealed environment with a whole bunch of people who couldn't bathe, not my kind of idea of fun. But probably most importantly is, well, I don't know, drinking is pretty important. It can also be used to create rocket fuel. And so the idea is, and I think I mentioned this before, is if you can find water ice, process it, and create rocket fuel on the moon, you now have a launching station, essentially, or you have the beginnings of a launching station. So instead of fighting the gravitational field of the Earth, you only have to fight the gravitational field of the moon, which is 1/6, 1 in 6 parts of the gravity of the Earth. So it is much cheaper and easier to launch payloads off the moon and then presumably to land them on the moon. Does the Moon South Pole Treaty prohibit exploration of the South Pole? No, it does not. Thank you, Rogue, for being here. Appreciate it. Yeah, I'm probably going to go for another 15, 20 minutes, maybe 30. Who knows? Might go nuts. No, but Clive touches on a pretty important thing, which I was kind of piggyback on this. Just to finish this off, this is going to be launched this month. It's going to use the same rocket as Peregrine did, but since that rocket was able to get the lander into space, that shouldn't be a problem. It was the vehicle itself that failed. So if they are able to do this, as I said, it is the first time that a corporation has a private business, private interest, will have landed a vehicle on a different world, on the moon. And they will have done so before one of the major world powers, that being Russia. Suck it, Russia. The USSR back in the day, they've landed shit on the moon, but Russia has not. And somebody might think that's a quibble or a semantic argument, but I would put forth that naively, I would still say that Russia is vastly different than the Soviet Union. But it's a major power, and it will have done so before. And so I've talked about this before. I won't get too far into the weeds with it, but it highlights that we are getting into an age where we really need to start thinking about how we're going to regulate this stuff. I know it's a downer. I'm being a Debbie Downer with trying to, pass laws and restrictions and all that kind of good shit. But, because I don't know how likely this is, but what happens if Elon just decides to say, fuck it, Malapert A is now my property. That entire crater is now the property of SpaceX. What's to prevent anyone from actually stopping him from saying that? I mean, granted, it's the Wild West. So the idea there back then was if you claim something, you have to protect it. So, which again it was problematic, because if you have somebody, and Musk is the type of personality that I really don't see this as hugely out of the realm of possibility, is if he lands something there, decides, all right, this is Malapert A, or Malapert A is now Malapert X, it's mine. And what if he sends up, I don't know, cannons or automatic guns to defend it, again, it seems, I'm laughing, it seems fairly ludicrous, but this is Elon we're talking about. There's nothing to stop him from doing that. And if he kills anybody defending his property, there's no laws on the books that say he should be held accountable in any way. This stuff is not sci-fi anymore. This is happening. This needs to be considered. I'm sure somebody is considering it somewhere, but sadly, the people I think that are considering it are the militaries. And the people I respect the military. My family is predominantly military. I have huge respect for the military, but I don't want them to determine actions that I do not want the military to set policy on how to prevent war. Military is really only good at war, not so much in preventing it, from my understanding. Could be wrong, but I still don't want them in charge of it, charge of trying to come up with ways to prevent, because those ways are going to more than likely be violent. And I desperately want the moon to never be a place of conflict. I'm not going to get that. I realize this. But if we are able to have any kind of regulation or treaties a priori before we even get there, if we can brainstorm as to what just the basic rules will be before Bezos gets there, for example, or if this doesn't succeed, Musk actually gets there later. If we can set those guidelines into place, at least for American privately owned American companies, that'd be a start. I mean, granted, there's nothing to prevent them from really, the Chinese or Russian companies or anything like that to take care to exploit the system. But again, it's something. Look at the chat. Emo Musk. I'm stealing that one. Elmo Musk. I'm setting that one. He's decided to tunnel there instead. I just heard something else. I think it was on Tune. He's like, yeah, all right, you've got, there are uninterrupted flights in the Southern Hemisphere. Now we've found effectively uninterrupted cruises, but what about uninterrupted train routes between Santiago, Chile, and Australia? I don't know. Maybe Elon will get on that. Oh, that's just boring. Nice, nerd alert. Green slime. Why is Judy bringing up green slime? I don't see that. Anyway, don't know what that's about. A starship that don't go down, go boom, boom. Yeah, and I think that's what Clive was referring to in the beginning, is that SpaceX hasn't had the greatest track record when it comes to having their starships not explode in one way or another. But this is not that. This is a lander. It's going to be on there. It's going to be launched using, what do they call it? A United Launch Alliance's new Vulcan Centaur rocket. Okay, never heard of that. So yeah, that's a thing apparently. So yeah, we'll see how it happens. So I wanted to bring that up again because I think it is noteworthy from an astronomy point of view, and again, it raises I'm going to keep beating this dead horse, this drum, to whoever will listen, that unless we start planning for how we are going to share the moon, shit's going to go down, and it's going to go down badly. So I will finish up this stream by talking about some sad news. I don't know if you know. Apparently, this is actually a little bit old, but it's new to me. Shows you how well I pay attention to news, at least space news. Is that Ingenuity is grounded. For those of you who don't know what Ingenuity is, Ingenuity is a helicopter. It's a dual rotor helicopter that was launched as part of the Mars Perseverance package, so Percy, as I like to call them. There was launched, I can't remember exactly when, sometime last year I think they landed. And so Perseverance is a rover. It's the newest rover on Mars. And it's going around a particular crater, starts with a J. I don't know, I'll get back to that. And it launched from itself Ingenuity, which is a helicopter. And I've been to a talk. I'm hoping I have it recorded somewhere, but it was a talk given by someone who studies Martian atmospheres. Actually, she studies Martian sand dunes, but because they are shaped by wind, she knows an awful lot about Martian atmosphere. And basically the main science goal of Ingenuity was to see if it was possible to actually have a helicopter have powered flight in the Martian atmosphere. The Martian atmosphere is significantly less than the Earth's. I can't remember by how much off the top of my head, but trust me, there's not a lot of air there. And so there was real concern that the blades would not be long enough to produce enough lift for Ingenuity to work. But lo and behold, it did because of terrestrial testing. And, say what you want about NASA, other than that they're faking this shit. When they build something, they build it to last. Spirit and Opportunity went years beyond. Granted, they could be doing a Scotty thing where they drastically underestimate the lifetime of their projects so they can seem like miracle workers. But the previous rovers of Spirit and Opportunity, I think they doubled. They lasted longer than twice their initial lifespan. Ingenuity was originally slated for, I think, 11 flights. It managed to do 72 of them. Like it, to the point that I remember when they finished the 11th mission or flyby. And the idea was Ingenuity was going to scout out areas of this crater, Jezero crater, scout out areas of this crater that Perseverance couldn't get to. The terrain was either too remote or too rocky for Perseverance to safely be able to navigate it. After the 11th trip, they're like, what are we going to do now? Like, where are we going to fly the thing? Because they didn't expect it to last that long, but it's lasted for a long time. And so what we're seeing here is right over here is the Ingenuity helicopter. It did not crash. It was safely landed on purpose. So this is taken by Perseverance. So this is the surface of the moon in true color. Excuse me, not the moon, Mars in true color, by the way. And 70, I don't think there will be a moon treaty. We technically already have one, but I haven't read it, and it's from like 1967, so I'm fairly certain it's not very robust. But the reason why Ingenuity landed, there it is, close up, super high res, zoom in and enhance, as they say on the tubes, is because of this. So, yes, we do occasionally put cameras on our instruments. So what we're seeing here is Ingenuity is shooting its own shadow. And you can see this is the shadow of one of its rovers, and oops, something happened where it something happened with the rotor such that it broke. Apparently this thing was out much longer than it intended to do, because again, because of light travel time, there's not someone at home sitting with a joystick just flying Ingenuity around. The delay is impossible for a pilot to be able to respond in any kind of real time in order to events that happen. So the flights are pre-programmed. Well, one of the ways that one of the things that the program utilizes are visible and identifiable landmarks. So basically, the Ingenuity knows where it is because we have not put a GPS system over Mars yet. It knows where it is based on visible cues. Apparently, during this flight, it launched over such a boring part of the crater that there were no clues, and it effectively got lost, or it took a much longer time to get back than they ordinarily would. And when it got and apparently during that flight, something happened. Maybe a Martian kid threw a rock at it. I don't know. Aliens. Might be aliens. Who knows? It broke. And so it is not defunct. It is not defunct yet, as far as I'm aware. They are going to attempt to quote unquote wiggle it. I think that essentially they're going to test the wings. They're going to test the rotors to see whether or not they're still able to carry the craft without crashing. But I have a feeling that sadly the 72nd flight of Ingenuity is now its last. So we have now added yet another robotic corpse to the surface of Mars. It is now becoming a robotic graveyard, for better or for worse. Let's see. Yeah, Voyager 1 and 2, real simple instruments. And Sagan, in his book, Playable Dot, he was talking about the success of Voyagers. And yeah, real simple instruments. And they have plenty of fuel. They're radioactively powered, through radioactive decay. So they got plenty of power. The issue is whether or not the instruments will last. But yeah, they seem to be. And they are, they were launched in 76. So the year I was born, hence why I know it. So they are 47 years old. And so, or roughly speaking, yeah, they're still going. They're just sending out a radio signal. I think it's something like the power of a 100-watt light bulb. It's basically the power of these devices. But if you have a strong enough antenna, you can still detect it. I heard that one of them had a problem and basically went silent for I think nearly a month, and then I guess woke up and started beeping again. And I think the other one is now starting to show signs of wear. So who knows? But I believe both of them have also passed through, or one has passed through and the other was passing through the heliopause, which is one definition of the solar system. So beyond the heliopause is the transition region between where the solar system is protected by the sun's magnetic field and where it's not. So it certainly isn't probably the best definition of solar system is beyond the Oort cloud, which these things have yet to even get to, let alone surpass. Claims are easily made. Let's see. Sable Eagle says 0.62% the pressure of the Earth's atmosphere and 1.6% the density of Earth. So yes, thank you, Sable. Very so. So The Martian, great movie, great book. Highly recommend both of them by Andy Weir. Everything seems to check out. Like, I'm not certain about the biology of, growing potatoes, but everything else really dead on, except for the inciting incident. Yes, there are huge dust storms on Mars. And yes, those dust storms can be global in extent. But that in itself should tell you something. The wind speeds on Mars are rarely, I believe, get over maybe tens of kilometers per second or tens of kilometers per hour. So the reason why that dust can be carried globally is because there's not a lot of stuff to slow it down, or it can travel very freely through the atmosphere. So the idea that the winds would be gusting so much that they, spoiler alert, blow Damon hundreds of 100 yards back into a habitat, yeah, that's not going to happen. But it's sci-fi. You have to have a little bit of fiction in order to spice these things up. Let's see. I didn't vote for you, and don't tell me that Lady of the Lake story, supreme executive power, derives from a mandate of the masses, not from some farcical aquatic ceremony, some saucy woman chucking scimitars at you. The audiobook version? Yeah. Yes, I'm not into audiobooks, although Mrs. PhD, and yes, there is a Mrs. PhD in that I've been seeing her for a few weeks now. She is getting me into audiobooks, and the first one I've decided I've tried to read Dune 3 times. Read Dune 3 times. Can't get through it. So I'm like, fuck it. Let me see, because my brother Vic, he swears by this. He loves this series. And I'm like, there's got to be something to it. So maybe if I hear it, maybe if I listen to the audiobook, things will get better. Nope. No, it's just boring. It doesn't matter what format it's in. Sorry, but Dune is boring. Didn't even get to the repetitive prescient bit. Just boring. But I am now going to read, or listen to rather, Carl Jung's Philosophical Types. So while I exercise. Hopefully, it's not boring either. But the audiobook is 24 hours long. So yeah. I will definitely be 50, or I'll probably be 50 by the time I actually finish it. So who knows? Like the video game, the computer game, one of the first real-time strategy games. I think I might have actually played that. I'm not big into RTS games, but I may have actually played that. Played that game. I have a vague recollection of it. Recently, I played the RPG that was developed by Morpheus. Not good. The mechanics are dumb. It is the 2D20 system, which is just may work, but the mechanics in the Dune system do not recommend. You could exploit the hell out of it. My Mentat was damn near superhuman. So basically like a Jedi and a non-Jedi party in any Star Wars campaign, just overpowered. Orison has an audiobook named Beyond Faith. I don't know who Orison is. Is Orison a philosopher? Is that where I know that name from? Not sure. But yeah, kind of just wanted to update you on kind of some stories going around space and such. Oh, and howdy, Eric. Haven't seen you in a while. Is the Darth Plagueis novel. Gives me lots of ideas. Dr. Wells, Orison debates on MDD. Okay. Well, maybe I won't check that out. Yes. Dr. Wells, if you start successfully raising people from the dead, I will be very worried. I will truly be very worried if that in fact happens. So definitely keep me updated. First audiobook I think I ever read, and although they weren't called that back then, and back in my day, I listened to, I was on a road trip with my half brother Eric, and we were listening to on cassette the radio play for Hitchhiker's Guide to the Galaxy, which was phenomenal, which is what got me into Douglas Adams in the beginning with. And then the second one I listened to was the radio play, the Star Wars radio play, which included what are now deleted scenes. So basically, there's an interaction with Biggs at the beginning of Star Wars, which is a nice tie-in to the back, and so it gets a little bit more. And also, there's a scene between Leia and Organa and her father, Bail Organa. I don't know. Talking about the Emperor. So yeah, there's a lot more like stuff prior to Tatooine. That was pretty cool. So I guess those are audiobooks, but yeah, those were pretty cool. I don't know. I just like the tactile feel of books, as I've said before. So, where do I have anything else to shout into the void? Oh, they took it down. Well, yeah, the Martian, the book was actually free from my understanding. Weir wrote it as a lark, and apparently he wrote chapters kind of like in a serial, and he would post them blog style to his website. And it was so popular that a publishing company approached him to publish it. And so I still need to read his latest, Hail Mary. I've heard it's very good. It's along the same lines as The Martian in that it's a solo, isolated protagonist. The second book that he wrote, Artemis, maybe? I don't even remember. Something about a lunar base. It was good. It wasn't exciting. It was good. It wasn't Martian standard. So he kind of had sophomore slump on that, but I would still recommend it. Okay, well now I'm just rambling, and I mainly because I don't want to go back to work, but I have a huge amount of work I need to get done. Because yeah, I'm observing tonight. Oh, woe is me. So Thank you all for being here. Again, I am Professor Parks, PhD. I make content on astronomy, science skepticism, and mental health. If you like that sort of content, please like, share, and subscribe, and hit that bell for notifications, because I don't know what a schedule is. I think I've seen one on TV, but I have no idea what that is. I post whenever I can. I don't always post on Discord. I don't advertise it usually anywhere. I'm trying to fix that. I'm trying to start advertising on Threads and Facebook, but those videos. So yeah, click that bell for notifications. If you have already clicked that bell for notifications, you should already have been notified that earlier today I put up the video Stephanie has mentioned of thank you for watching that, by the way, of Dr. Erica Hamden. Gave a talk at our Evening Under the Stars about ultraviolet astronomy. If you if you are willing to support me in my efforts in this new YouTube career, and also our observatory and tour guides, please consider financially backing us by becoming one of my patrons, donating through PayPal, or becoming one of the 2 channel members that I have. Which reminds me, I still need to update the outro, because I now have not 1 but 2 members, Bellywood and Dora. Dora is now both a patron and a member, so thank you. With all of that being said, again, thank you all for being here. Thank you all in the future who are watching this on Memorex. I love doing these things, and being able to do these lives and interacting with y'all really helps motivate me, at least to do this, if not to create more targeted content. So I literally could not do this without you. All right. With that, peace out, clear skies.